Hello friends, in this video we will discuss a development of lateral surface of the truncated cone. A cone of base 60 mm diameter and height 70 mm rests with its base on HP. With this we can say top view is the circle and front view is the triangle. A section plane perpendicular to VP and inclined at 30 degree to HP bisects the axis of the cone. Bisects the axis of the cone. It is midpoint of the axis. 70 mm is the height of axis, so bisects the axis. This is 30 mm, 35 mm. Draw the development of the lateral surface of the truncated cone, and we will proceed the answer xy and draw the circle which is diameter of 60 mm. Either we can divide this circle into 4 division or 8 division or 12 divisions, so we will go for 8 divisions for better accuracy and make it as A, B, C, D, E, F, G and H. So you can extend a projector for the completion of front view from the boundaries as well as the divisions whatever we made, and complete the front view. O dash apex or vertex and boundary alone should be there for us. Always start the simple position by means of thin lines. After the completion of section plane we can convert this remaining portion into thick line. Either this OC, is on the axis, so either we can represent as axis or we can represent it as the divisions like continuous thin line, and give notations. A dash is visible and this C dash and G dash is invisible. This top half F G H, it is invisible from here as an observer standing here, so this is well known to us. And complete E dash here and mark O dash. Now the simple portion is completed. Section plane we have to start. 30-degree inclination bisects the axis of cone. So total height it is 70 mm. So midpoint of the 70 is 35. Midpoint of 70 is 35. That is the bisects the axis of cone. Now you have to draw the 30-degree inclination with respect to HP through this midpoint of the axis. This is 30 degree with respect to HP. Make it as a section plane now. Identify the section plane cutting points. Before that, convert the remaining portion into continuous thick line. Above the section plane. Above the section plane, this is the removed portion, and below the section plane, it is the remaining portion. Being the cone, only the boundary surface will be there. So convert the boundary surface alone into thick lines. No need to convert this split ups divisions. Okay, so boundary surface of cone has to be converted into thick line in the remaining portion. Now we can go for the section plane cutting points. In O dash A dash is the first cutting point, 1 dash. Next on this 2 dash Y 8 dash B. On the same projector we are having H. So last point of the division is 8 divisions, so it is 8 dash in the bracket. Similarly in case of 3 dash we will have 7 dash of G. Okay, so OG we will have the 7th point, so the 7 dash in the bracket. So next one it is O dash E dash we are having O dash F dash we are having, and O dash D dash we are having 4 and 6. So I don't have sufficient space, I represented only 4 dash. Finally it is 5 dash on O dash E dash. So we know that in radial line development, we have to shift all the section plane cutting points to the end generator, either to O dash E dash or O dash. This is O dash and A dash. We have to shift all these section plane cutting points 1 dash to 8 dash to this end generator. So by means of extending the projector parallel to XY, shift all these section plane cutting points into the end generators 2 dash 3 dash 4 dash 6 dash. Okay, so we have shifted all the endpoints of all the section plane cutting points into the end generator O dash A dash. So this is the true length of the end generator. O dash A dash is the true length of the end generator. Now all the data are available for to available to start the development of lateral surface. First we can check one more formula is we have to remember, fix any point on the sufficient space O, and then this is theta is equal to 360 degree into r by L. It is very simple. Circumference is equal to 2 pi r. 2 pi is 2 into 180 is 360, r it is, and this theta L for slant edges. So we need theta alone and divided by L. So L is the true length of slant edge. What is the true length of true length of end generator? Slant edge in case of pyramid. True length of end generator. Here O dash A dash is the true length of end generator. O dash A dash is the true length of end generator. You measure the distance of O dash A dash, substitute for L. R is the radius of the diameter. Radius of the base cone. 60 mm is the diameter. So radius is 30. O dash A dash is equal to 76. If you draw using it, may be around 76 point something. So what I did is I have rounded off that value. 260 degree into 30 is the diameter of 60 is the diameter of cone, 30 is the radius of the base cone. Then 76 is the true length of the slant generator O dash A dash. So what I obtained, theta is equal to 142 degree. Now you can use the similar way of radial line development we followed in pentagonal pyramid previous video. If you wish to see those video, you can check it in the description box for the link. O as center, and what is the radius of this arc? L is the radius of the arc. L is 76 mm. So L is the 76. Use that 76 as radius, complete the arc. After completion of this arc, you can fix any point on this arc. You can fix any point on this arc. What is our division? 142 degree divided by 8. It may be around 17.75, I think. If it is 17.75, I may not convert 17.75 in the protractor. So you can make it as 18 and complete 8 divisions. For that completion of 8 division, either you can place your protractor on the first end generator, and for this next end generator it is 18. For next it is 18 plus 18, 36. Likewise you can do. Or else you can fix the both end generators. These are the both end generators. Now it is 142 means in between end generator, mid of end generator, it is 142 divided by 2 is 71. Then you can divide that 71 into 2 as 35.5. Like that also we can do. Whatever convenient way for you, you can go for it. Either place your protractor on the first end generator. From that protractor you can mark 18. So next one is 36. Then again 36 plus 18 is 54. Again 54 plus 18. Likewise, if you have a calculator, you can once place a protractor, mark all the end generator points. Not end generator, divisional points from 1 to 8. So likewise you can divide into this 142 degree into 8 divisions. Okay, after identifying 8 divisions, we can mark A, B, C, D, E, F, G, again H, again A. So this radius is the true length of the slant generator. So true length of slant generator is O dash A dash in the front view. O dash A dash. Okay, now you can reproduce this one O dash to 1 dash on OA slant generator. So mark 1. Next is 2. For this what we can do is use your compass. O dash and this 2 dash as radius. O dash and this 2 dash as radius, because 2 dash and 8 dash lies on the same projector. You can check it here. Same distance. 2 dash 8 dash on the same projector. You can measure from O dash as the center, measure the radius as 2 dash 8 dash. 2 is on OB. OB we are having 2, and in OH we are having 8. So use O as center, cut arcs as the same radius on OB and OH. Similarly, for 3 and 7 on the same projector, O dash as center, 3 dash as radius. Use here the same O as center. 3, 7 is on OC, OG. So here OC cut one point and OG cut another point. Similarly, you can go for 4 and 6 on the same projector. So with the help of that, we can complete all the 1, 2, 3, 4, 5, 6, 7, 8 divisions. It has to be reproduced from this front view to this development of lateral surface. Now we can join all these by means of continuous thick lines. Okay, continuous thick lines, you can check clearly. This is the removed portion from o dash to this points 1 2 3 4 5 6 points is the removed portion. That's why you have to remove keep as it is. This o2 1 1 o2 all the points, it is the removed portion, keep as it is. Bottom of the remaining portion, and never ever convert this divisions into thick line, because if you convert this divisions into thick line, it is the combination of pyramid and cone. So no need, it is a curved surface. You can convert the boundaries of this cone alone into thick lines. Okay, this is our final lateral surface of the truncated cone. So here you have to remember this formula. Always remember circumference of the cone, it is 2 pi r. So L theta is equal to 2 pi r, and 2 phi is 2 into 180 degree 360 degree, and r is the radius of the cone. L is the true length of slant generator. You can measure it from the front view. After identifying this inclination only, you can divide this into 8 division, 142 degree into 8 division. As per your convenience, you can divide this 142 by 80, 8 divisions, 18 degree. Approximately if you take 18 each, so it may comes around 144 instead of 142. So okay, and afterwards you can reproduce this O dash to all section plane cutting points on the respective divisions. Finally complete the answer for this particular question. And if you wish to see the previous videos like hexagonal prism, then vertical chimney, then pentagonal pyramid, development of lateral surface problem, you can refer to description box for the link. If you like this video, click the like button and share with your friends. Don't forget to subscribe this channel for further videos.